cat. Animal. Okay, so that's actually quite a lot. So let's go and deconstruct what's happening here, right? So a dog has an animal, or a dog is an animal. A dog is an animal. Not has an animal. A dog is an animal. Yeah. A dog is an animal, and a cat is an animal, right? So that means that if a dog is an animal, it has to have an instantiation of its base class inside of it. So that's why we're initializing animal here to something, and we're initializing animal here to something. Everyone see that? So, right, there's cool. Okay, so there's the differences between those, right?
So
we need to implement growl. So, why do we have to implement growl here?
Because it's pure virtual. So.
I'm sorry? Kind of. You're writing everything. Okay. Void. So this is growl. Okay.
It's pure virtual. So
the reason why the dog and the cat must implement growl is because animal is a pure virtual function, right? So we cannot instantiate this, but what we want to do is be able to call all of these functions that an animal has, because animal is our abstract interface, which means that dogs and cats must be able to call these. So if I make a base class pure virtual and I derive classes from it, then the derived class must implement the pure virtual function.
Let's say you have another function in animals. Do you also have to write virtual and set it equal to 0?
In another function in animals?
Yeah.
So, in order for any class to become an abstract class, you only need one function that is pure virtual. It's a virtual equal 0.
So you can have the same function over there, same name and everything?
Same name, no virtual equal 0. If I put virtual equal 0 over there, now this is also an abstract class. And so this cannot be instantiated. So you can't have knowledge reviews.
You only do pure virtual once.
You only do pure virtual for the class that you intend to be an abstract class. Yes.
What is the difference between virtual and pure virtual?
The difference between virtual and pure virtual is that a virtual, okay, guys, if I make a function that is virtual, right? If I take the equals 0 out, then animal is no longer a pure virtual, animal is no longer an abstract class. It's simply a regular class. That means that I can have an instantiation of animal. Like the thing that Alex wrote up on the board earlier, I can say animal, A, and then that object will be created. Whereas if I set it pure virtual, I'm saying that this can never be created. The virtual stays the same. The virtual means that if I have an object of type this, and then I also point, or if I have a pointer to type this, and then it's actually pointing to a dog, I will print out the dog. Versus if it was pointing to a cat, I'll print out the cat, right? So here a cat will probably also have some kind of void growl, and I'll be like, I am a cat, and then it's down. Whereas this will maybe be something like, I am a. So the whole point is that we're trying to make a situation in which I can have any type of animal stored in some kind of container or something. But it could be either a dog or a cat, and I won't know until runtime. That's what the virtual is for. The equal 0 means that the class cannot ever be instantiated. So they're two different purposes, but they kind of go hand in hand, right? Because sometimes I don't want this to be instantiated. Sometimes I want to be able to have a situation where dogs and cats exist, but not animals. Whereas other times I want to have a situation where maybe this exists, and then the other two can also exist. In other words, the derived classes and the base classes are all real things. Like for instance, maybe I have car frame, and then derived from that is Honda, Toyota, whatever. I can have a situation where car frame is a real object, and I can make instances of that object, but I can also make instances that are different car manufacturers that derive from that object, right? This is a case where I don't want that. That's why I'm making it an abstract class. An abstract class is just the idea that there is other things that implement exactly this. That makes sense.
Wait, so to clarify, if it's an abstract-based class, you can't make animal, but if it's just virtual, then you can.
Yes. If this is just virtual void, then all I'm saying is that this particular function gets resolved at runtime. And what that means is that you won't get any compiler errors trying to call, dog growl versus animal growl. But at runtime, it will figure out, oh, is this an animal or a dog or a cat? Then it will go and pick out the function that implemented whichever one it is, right? Because they're all named growl. But at runtime, it will go and find the function that belongs to dog, cat, or animal and call that one based on the type that the object is. Whereas the equal 0 means you can never have an animal in the first place. Three more questions.
When you have the virtual right there, for like the dog class and the cat class, do you not redeclare growl? Do you have to have this? You have to have the void there.
Here?
Let's say
You
like
cannot change the function declaration here. It has to be a void class because this is a void.
You will need to override something.
Yeah.
Override that.
Yes.
But let's say you have a function growl in the animal class that you want to call to have exactly the same thing come out of the dog class.
Then you don't have to override it. Then you can't make this.
You can't make it equal to. If you don't make it equal to 0, you don't have to redeclare. You can just call growl.
So if this was not equal to 0, then I could just say this is equal to the same as that, and then just call growl.
Okay.
Yeah. But again, because this is equal to 0, there is no growl in existence. Right? This entire animal object doesn't exist. I cannot go in here and say animal.growl. Right?
So, I guess like onwards to like polymorphism stuff. What if I could define like a generic sound for an animal? So someone give me some random sound. I don't know, knee or something.
Knee.
Yeah.
What?
Here's nice to say. So, what if we can define growl as this? It just prints out me. So, what if I have an animal pointer? Let's say I'm in my main function, I have an animal pointer. Okay.
Yeah. That'll be a lot better. I don't know why we did not use this slide.
Can it see that?
Can it?
Miguel?
We don't.
Yeah.
Let's have an animal pointer A, and let's make this a dog. So new dog. Yes.
Yeah.
And I say dereference and access a method, and this is going to be where? What's going to be output to the screen?
Well, I'm just going to give a quick warning, but there's no guarantee that all of this code is syntactically correct. We're trying to convey the concept here, so don't worry about you should know on your own whether the syntax is correct or not from actually coding.
So, given this type of the code and given those definitions, what is this output?
That outputs dogs.
I am a dog. Is that really what the dog says?
I would think it would be
It's going to print out. I am
Come on.
A dog.
dog like this,
And then it barks.
and then barks.
Yeah.
Something.
Please put bark.
Okay, bark.
Talking dog.
Yeah.
So what if in my class definition I went over here and I just did that? What is this going to output now?
That output animals from.
It's going to put out, the animals version of growl, and it's going to say me. Now this is a weird dog. It can talk, it can say me. So what's the difference between these two types of binding? So we call this one static binding, which happens at compile time. So it just says that, oh, we have an animal, we have an object of animal, so I'm going to use animals version. But if I say virtual, this gives the compiler a clue, and it says like don't try to figure out which method this is until runtime. And then at runtime, this sees that this is pointing to a DOM object. So it's going to call DOM's version of growl. So any questions about that?
does making something a pure virtual affect derived classes at all, or it only affects the base class?
It only affects the base class. I'm only not, so it kind of affects the derived classes in that it must implement its abstract methods, the wishes to derive from that class, but otherwise it's unaffected. So does that answer your question?
So if you get rid of virtual, then you can never call the dog brown.
I can if I just make a dog object d dog.
But then the whole point of this is that this kind of ruins our idea of polymorphism, right? In the sense that I can no longer have an animal that points to multiple types of animals, and then they can use them mix and match accordingly, right? Now I have to have a dog, and it has to be created as a dog, and I can't have a container of dogs and cats mixed together, right? So if I tried to make like a vector of dogs and cats, I wouldn't be able to do it.
So is virtual dynamic binding?
Yeah, when I call virtual, it does something called dynamic binding. It tells the compiler to resolve this binding at runtime and dynamically binds that method call. Those words probably make sense.
To use this method, you have to use a pointer, right?
Yeah, you have to use a pointer because I cannot I can't make an animal like this.
What if you were to make a virtual feature? A pointer and then make a virtual spot.
If I make it pure virtual,
For the animal class, and what if you make it like pure virtual functions? You can't actually make it involved, right?
You can still make a pointer to it.
yeah, you can still.
So even if it's a pure virtual function, you can still make a pointer to it. You just can't make it. You just can't make an explicit instantiation of it.
And when you call that function, it'll call based on whatever the object is.
Yes. So you do it like that, and then you call that. It'll call the function based on whatever it is at runtime.
Good question. So
So if you make animal, the animal pointer or dog pointer is the same, is it just the same thing as creating a dog object?
yeah, but then again, that
Yeah.
kills our whole like nice polymorphism thing. So like, what if I want to display all of my dog, like all my
All of your
animals?
animals. Say you have a billion different types of animals.
Yeah. So I'm gonna have to make.
You are a zoo.
I need to like for my zoo program. I need to actually like say output all of my dogs, then output all of my cats, output all of my giraffes, whatever, and then like why can't I just say output all animals? So that's the point of polymorphism.
So you would need like 5 vectors for each animal.
Yeah, that's like the slow way.
Right. So if you did it without polymorphism, you have to explicitly say all these are dogs, all these are cats, all these are other things. Right? Whereas here I can just say all of these, everything is an animal, output all animals, and then at runtime it figures out what each animal does based on its overwritten functions here. Yeah.
So when we use virtual, you're overriding that class, that call?
You are not over. When you use virtual, you are only saying you're basically marking this function as saying this particular function gets resolved at runtime. But if you use pure virtual, then all things that derive from it must override that.
Okay, so only when you use a pure virtual.
Only when you use a pure virtual do derived classes have to override that function. But the virtual itself doesn't say anything about this function being overridden from.
Okay. Next topic. Next topic. Yes.
Dynamic memory.
Okay.
What do we have for dynamic?
I don't think I have any. So why don't we do the last question?
The what? Oh, the stack and heap one? Okay.
I'm not sure about
I think it. Okay, so the trick between dynamic memory and static memory, right, is the fact that they exist on two separate portions of memory. So in your computer, memory is just one giant block. It's literally that disk of, if you ever bought like RAM, it's that stick of thing right there that has a million spaces. But in our program, we separate that to two ideas. One is the stack, which has a specific property that as you add things onto memory, right? Say this is the top of the stack. I can only put it at the top. So I can only add it here and say this is new top, right? And then if I want to take things out of memory on the stack, I have to take it from the top and then move down. So that's a specific idea of the stack. Then we also have a heap, right? And the whole point is that it's just some thing that exists somewhere where things get put into it. There are really, the compiler will figure out everything about how things go on the heap for you. You don't have to think about it. But the heap is basically where we want to put anything that doesn't really belong on the stack. So where do things not belong on the stack? Usually when we're talking about arrays. Arrays have to be a fixed size when on the stack, right? Because otherwise I can't know where the top is and how to pop it on or off. If my array starts at size 100, then I know the top is 100 spaces plus something above it, right? If it suddenly changes to 1,000, I would have to magically move the top even further up. Otherwise, I don't know where it is anymore. So it's cases like that where I want to say, you know what, let me put that on the heap and then worry about it when I have to worry about it. And then the heap will figure out, well, it's 100 here. If I ever change it, I just change the pointer to it, and now it's 1,000 somewhere else, right? So we have this here, and somehow I thought you were doing something else, because the numbers are different. So we have this here, right? And what we want to do is show how the stack and the heap are reacting to these statements. So let me clean this up here.
So for the heap, you borrow things on the fly. So you borrow things from the heap, that's invoking new. I want something from the heap. And delete is I'm freeing things from the heap. I don't need them anymore. I'm returning them back. So think about Blockbuster. I can rent videos, and then I need to slice. Blockbuster doesn't exist anymore. But like, I need to eventually like give them back to the heap, or I'm gonna get penalties. I'm gonna pay penalties or something.
Or Blockbuster's going to burn down and go out of business.
Memory leaks.
This actually makes more sense. Memory leaks.
Yes.
Think about it. If you don't return the DVDs, Blockbuster loses all their money, and then all of them crash. Okay, so here's our stack, right? And we always start with main. And so in vector is probably something we can wrap it around the main. So remember, the stack basically takes functions as they go on top, and then the functions themselves have the variables inside them, right? So here, when we started off, we're going to start with main, and then we're going to instantiate in vector b, right? So b is basically going to be in here. Belongs to main on the stack, right?
And if you guys remember, in vector b has three components. It has three stack components. So one is a pointer to integers, which is data. The other one is an unsigned value, capacity, and the other one is the unsigned size of the value.
Size, capacity, data, right? So these belong in vector b, which belongs in the main stack, right? And so data is pointing to nothing for now, right? But once we try and push back an item, we have to grow data, right?
Yeah.
Data is going to point to something on the heap. So, let's say it points to.
It's going to point to the beginning of.
0, 1, 2, 3, 4, 5. Let's just say it, for some reason, points here, right? Because we don't actually know how the heap works. We just know it places it somewhere on the heap. So now I pushed it back. That means, and you implemented int vector, so you should know how it works, right? That means that we're going to say data, it points to a new array of size 1 on the heap. And we'll say it starts at 4. Because again, you don't know where it is.
Okay. So what if I do another pushback? I've actually reached my capacity. Since like the first initial, so increase capacity to size 1. So now I need to double that capacity to size 2. So what happens? So I need to actually deallocate that the memory I just allocate for data. So I say delete data, and I copy over the data from the old dynamic array, and then I add in my new thing.
And again, you implemented this, so you know what you're doing, right? But the whole point is that I'm going to copy this and make a new array on the heap, right? And then let's say it decides to put it at 2 now, or I'm sorry, at 1 now. So it'll say this is 8, and that my capacity is of this much, because we doubled it, right?
Yeah.
So now data point's there. 8 still exists here, it's just no longer valid, right?
And then we push back.
Right. And then the last call to the pushback, we again are going to hit our limit, right? Because we only had it at size 2, so now we're going to double the capacity to size 4, which means we have to change this once again. Now, say it decides to put it back at 3 or something, right? Actually, 2. Let's do that. So we can put it to 2. No. Can't put it to 2 there. So if I haven't deleted that, I can't put it there. Let's say I decided the compiler decides to put it at 3, and it reserves this much space. Notice that 8 here was the way it was before, but since it's free, the compiler can say this much stuff is the new array. And then I'll push 8, 42, and 619 onto it, right? And then there's one more slot there too. So in other words, how the heap is working is that once you delete something, I'm just marking the data off and saying I can use that space again, right? And so when I come back and say I need more space, it can say, okay, well this array I can mark off now. No one needs it anymore. This space you were using it before, but then you freed it. I can say this is your new array of size 4, right? And now it points to that instead. So see how that's changing, where all the time the stack is just got this one thing here, size, capacity, and data, all of which are fixed sizes, so it never ever moves.
Any questions?
Any questions about that? How dynamic memory is working?
So yeah, you guys implement injector, and I just add this new pointer to point to the old buffer. If you guys did not, in fact, you need to actually keep track of the old buffer on top of the new buffer you just allocated, so that you can copy elements starting from here up until you reach your size, and just hop them over to, starting from where data points to, and all the way to its new size. So any questions?
So again, there's nothing special about dynamic memory. It's not saying that I can change my array willy-nilly. Like, there's no magic resize thing that just fixes everything for us. I still have to move it around and make a bigger array, right? The whole point that it's dynamic is that it can exist on the heap, which means that it can find memory for me to fill in with that array.
So just like the golden rule, if I'm initializing new variables like I used to, that goes on the stack. If I'm using the new operator, then that data goes into the heap, and delete will erase that, or like it will mark it for deletion on the heap. So any questions? Pretty straightforward.
So when we add, it's always doubling, or that is the
That's how int vector works. That was just the assignment that you guys wrote for one of your labs or something, I think.
Yes.
But that doesn't necessarily mean it's always doubling. How it's growing is just based on how you're reallocating your array, right?
But in
Again,
implementation, we're just doubling
yeah.
our allocation.
So it's just this particular implementation that you're doubling.
So what about for int list? I want to allocate one new node. I'm always going to be, when I want to push from something, I allocate one new node, because I know that I only need one more item. And all I do is link that block in memory to other blocks in memory to create a linked list. Does that kind of answer your question?
Okay. So like with that, you don't have to double the capacity, right? Every time all you're actually doing is allocating a new block. So a linked list can go, the blocks in the list can actually be in various places in the heap, right? Yeah. Any questions? Yes.
Go through stack again, like how it works. Cause I kind of like got lost when you're putting stack.
Go through the stack.
Yeah.
So here the stack does nothing. Are you talking about how it goes on?
Yeah.
Here the stack does nothing special. Let's actually write some like silly thing that does nothing.
That does more things. Yeah. X.
Yeah. So let's say here I'm going to do food and then bar, red bar. Or actually call bar inside series. Okay. So what do you expect? So here, like with stacks, right? What's going to happen is that whenever it hits a function, basically, it's going to say, well, if I'm going to call this function, then I'm going to have to add that stack frame of that function onto the stack. So right now, the top of our stack is main, right? That's where we started with. And the variables declared in main are v. That's it. if now by the time I get to that last pushback, I just have to call foo, it's going to jump over to this stack right here. And this is foo and declare two other variables, x and y, right? So I'm going to have to push foo onto the stack. And inside this here is int x and int y. They exist right here. And again, these are fixed sides, right? And you know that integers are always 4 bytes or something. And so you know exactly how big this foo is. It's 4 bytes. There are only 2 variables in it, right? Same thing with the vector. You know how big this is because it has int and pointer. Same deal, right? So once I have foo here, then I push that onto the stack. And then you see that in foo, I'm calling bar. So bar has another variable here in z, right? So the whole point is that for each function that I call, I'm going to push it on the stack. And then when I'm done with bar and I go out of scope here, I can pop that off the stack, right? So you know how, our variables that we declare in a particular scope go away at the end of the scope? This is what's happening. Once it's gone away, all I do is simply pop it off the stack. I mark all of this and say, this is no longer memory being used, and I go down one, right? And I just, again, with pointer arithmetic, I know how many bytes this was, right? I can subtract that and say, I'm correctly at the last stack frame that I was, which is foo. And then I go out of this now, and that goes away too. And all of these are saying, this memory is free to use again, and I'm back down to main. And then I return, and then that literally pops off. Your program's done. That's all the stack is doing. For every function that I keep calling, I go up. Whenever that function is done, I pop it off. So that's really all you need to do. Yeah.
So what about global variables?
Global variables actually exist.
They exist outside the stack.
Yeah.
So you can kind of pretend they're their own entity, but they have global scope. So like he talked about like a few different kind of memory regions. So he talked about the heap, the stack, and something called static memory, which includes globals. So I'm pretty sure you're not going to be asked about that.
I probably will not. Any other questions? Okay. Where are we at? Recursion now? Okay.
So we've been doing kind of a lot of work. So we're going to have you guys do a problem. So get out some pieces of paper. I guess like
I'm gonna put some like this.
something like this. Sure. So pretend you have your list class from your assignments, and you also have access to Node. Do you guys remember what Node has? Node.
Data.
It's called a struct. So let's pretend we have a struct like this. It's going to be a struct which has 2 pieces of information, the integer value we care about, and the pointer to the next input in my inputs. So I want you guys to actually implement a function inside the scope of intlist. So you guys have access to at least the head and the tail of intlist. So it's going to return an integer. And the header is going to look like this. We want you guys to implement a function which sums up all the elements of int list recursively. So no iterative implementations. So we'll give you guys like 5 minutes to do this. This shouldn't be that big. So you guys have until, what? 5 minutes.
I don't know, 5 minutes. It should not take more than 5 minutes. I'm pretty sure this is like 3 hours. All you have access to is the head pointer and the tail pointer. No like size or anything. Okay.
And pro tip, writing a helper function will help. Writing a private helper function will help as well. Slash make this possible. So remember, you only have access to the head and tail.
That's not true.
This one was